right, this is day 2 of lesson 4 for complex numbers. So today we're going to do operations with complex numbers. So adding, subtracting, and multiplying. And I'm going to just show you division, but we're not going to actually have you practice any division. And that's actually the hardest one. So you're getting off easy here. So let's go ahead and just talk about what you do with each one, and then we'll go ahead and do some practice examples. So for this first one, addition, it's kind of just combining like terms. Subtraction, in a sense, is combining like terms, but you have to distribute that negative to the numbers behind it. So subtraction can be a little tricky just because you have to be careful. Multiplication is distributing and foiling, which isn't too bad. But then again, you've got this x, if you have this I squared, we have to change that to a -1. So that's another one of those things you have to remember as you are working. So let's go ahead and start off with addition. Remember, addition is the combining of the like terms. So we can only add those things that are alike, meaning real with real and imaginary. There we go. And imaginary with imaginary. So combining those like terms, we add the -2 and the 3 to get 1. We add the 4i and the -11i to get -7i. So go ahead and try this next one on your own. Number 2, adding, again, like terms with like terms, the real with the real, and the imaginary with the imaginary, and add those like terms. So hopefully when you took 3 plus -2, you got 1, and when you took 7i plus 3i, you got 10i. So that is your final answer. Again, we write the real at the beginning, and then we write the imaginary behind it. That's the form of our complex numbers. So subtraction, that's the one where you have to distribute that negative first, and then we can add those like terms. So be careful and make sure you subtract that negative. It's like there's a -1 in front here that we have to give to both before we can add. So it's 4 minus I minus 5 minus 8i. Now we can add our reals together and our imaginaries together. So 4 and -5 makes -1, and -I and -8i makes -9i. So try the next one, number 4, on your own. Again, make sure to distribute that negative first, or if you want to think of it as a -1, distribute that -1 first, then combine your like terms. All right, so let's check. You should have had 10 plus 6i minus 3i plus 12. And then you're going to want to go ahead and add your like terms. So real and real, imaginary and imaginary. And we would wind up with 10 plus 12, which is 22. Again, real comes first. Then 6 minus 3 would be plus 3i. So that's your final answer there. All right, multiplications. This is the distributing and the foiling part. So it just depends on how many terms you have. So we're going to, on this one, distribute, making sure we multiply everything times everything there. So we take a 5 and a 2 and we get a 10 and we leave the I behind it. Then we take a 5 times a 3 and we get 15 positive. Then we take an I times an I and we get an I squared. Now remember, I squared is equal to -1. So be careful and make sure you change this to a -1. So we have this right here, or you could put it in parentheses if you want to. This is multiplication between these two. So we need to multiply 15 times -1, and we get -15. So since we would have -15 here, we don't want to write it like that. Remember, we want it in this a plus bi form where the imaginary is behind the real. So this -15 should be in front, and then the positive 10i behind it. So we want to keep our answer in that form. So trying the next one, we wind up with foiling on this one. So first term times first term, -12. Last term, or outer terms there, would be negative times negative, so positive. 3 times 5, so 15, and the I goes along with it. And then inner 2 and 4 multiplied to give me 8, and the I along with it. And then the 2i times -5i would give you -10, and then it's I times I, so I squared. So remember, we're going to end up changing that I squared to a negative 1. Don't forget that. So you can combine those like terms. I'm going to go ahead and do that to get 23I. And then I'm going to change that I squared to a negative 1. So negative times negative would make that a positive 10 that I'm going to then add to that negative 12. So I wind up with positive 10 plus negative 12 would give me negative 2. And then I put that in front because my real goes in front and then my imaginary behind it. All right, I want you to try these last two examples on your own. Again, be careful when you take the I times the I and get I squared. Make sure it's a negative 1 that you then change it to. So FOIL number 7, and then you're just ending up multiplying these two together and then simplifying on number 8. So try both those, pause, and then check when you're ready. So foiling on this one would wind up giving you 24 minus 4I minus 24I plus 4I squared when you take that last term times that last term there. So then we want to combine like terms there in the middle to get negative 28I. And then we're going to take plus 4 times that negative 1. So that I squared changes to a negative 1. So we have 24 minus 28I minus 4. And we combine our real parts and put them in front. So that's a 20. 24 minus 4 is 20. And then we keep our negative 28I behind it. All right, the last one, 6 times 6, 36. I times I squared. And the I squared becomes a negative 1. So 36 times negative 1 is negative 36 for number 8. All right, we're just going to look at division. Again, we're not going to have you try it, but we're going to look at it. So back at the beginning when it talked about division, we're actually going to skip back to that. We first multiply the numerator and denominator by its conjugate. So let's talk about what a conjugate is. It is basically the opposite of the imaginary part. So we just switch the sign on the imaginary part. What that ends up doing is kind of helping cancel it out. It's almost kind of like rationalizing that denominator. It looks very similar to that type of thing. Then we change any I squareds to negative 1s. We combine like terms and we reduce. So this example's worked for us, so let's take a look. Here's the question. We then multiply the top and the bottom by its conjugate. So if this is a minus, then our conjugate right here would be a plus. So that's what makes it a conjugate. The imaginary part is opposite. So we do that on the top and the bottom when we multiply. So we just talked about foiling. That's all you're doing, is taking and multiplying this times this and foiling. So here's what you get on the top, and then foiling on the bottom here. Here's what you'd get on the bottom. So then we change, the next step was changing I squared into negative 1. So the last one's here. That would make that a negative 15 and a positive 25 when we make those negative 1s. And then we just combine like terms. So on the top, we would add our i's, add our reals, and we'd get the answer for the numerator. We would add our reals on the bottom, which actually end up canceling out, which is why we do the conjugate, because it's kind of like we don't want a radical in the bottom. We want to get that simplified. And then 16 and 25 would add, and then we write it in kind of that imaginary and real form. So if we wanted to separate it, it'd be negative 7 over 41 for the real part and 22I over 41 for the imaginary part. So to summarize, definition is, remember, our real A plus BI, kind of for our complex number form. And then for adding, we just combine like terms. And then for multiplying, you either distribute or FOIL. Distribute / FOIL. And remember that I squared equals negative 1. And then the conjugate, which we talked about and only really need for that division piece, is just changing the imaginary sign. Change imaginary numbers sign. Right, and that's the end of this lesson.